Hello students, in this video we shall be dealing with the nomenclature for branched chain hydrocarbons. So I have given one example where I have shown there are 4 carbon atoms having one branching. So how we will nomenclate this example? First, count the number of carbon atoms and check the longest chain. Counting will start from that side where the branching group comes smaller. Okay, so here I have counted from this side, that is 1 2 3 4. So the branching position comes at the 2, hence the name becomes 2-methyl butane. That means the alkyl group which is present at the branching position is named first with its position, that is 2. Alkyl name is methyl, and to the carbon chain where it is attached, that is the straight carbon chain, butane. One more example I have given here. CH3 CH double bond C single bond CH3, CH2 CH CH3. So numbering starts from this side 1 2 3 4 5 6. Reason behind this is that there is a functional group double bond also present. So here double bond has the priority, so number starts from that side where the double bond position is smaller. So its name becomes 3,5-dimethyl, as methyl group is at 3rd position as well as at the 5th position. So it becomes 3,5-dimethyl, and the straight carbon chain is hex 2-ene, as the double bond is present between 2 and 3. So the number with smaller carbon is taken as the counting number. So it becomes 2-ene. Okay, here I have taken one more example. Let's see what is the name for it. Okay, so here comes the hydrogen. Here no carbon is having hydrogen. Now here one hydrogen will be coming, here one, and here one more. Okay, so how we will count? We'll start numbering from that side where the position of double bond is smaller. So it becomes numbering as 2 and 4 is having the alkyl group. So this becomes 2,4-dimethyl. Straight carbon chain is 5. So it becomes pent. Double bond is at 1st and at 3rd position, so it becomes 1,3-diene. So the name becomes 2,4-dimethyl pent 1,3-diene. Okay, one more example is here. Let's see this also. First we'll fill the hydrogen. Now here double bond and triple bond both are there, so priority will start with the double bond as it has more priority. 1 2 3 4 5 and this is 6. Okay, so the name becomes 2-methyl. Straight carbon chain is having 6 carbon, hex. Double bond is coming between 2 and 3, so it becomes hex 2-ene, and triple bond is coming between 4 and 5, so it becomes 4-ine. So this is the nomenclature for this example. Okay, now let's see what are homologous series. Homologous series is a group of organic compounds having similar structure and similar chemical properties in which the successive compounds differ by CH2 group. So here I have taken example like CH4 methane. To this when we add CH2, it forms C2H6 ethane. Further when we add CH2, it becomes C3H8 propane. Further CH2 when added, it becomes C4H10. Further when CH2 is added, it becomes C5H12, and this way the homologous series continues. So the general formula for homologous series of alkane is CnH2n plus 2. Now what are the characters of homologous series? First, all the members of homologous series can be represented by the same general formula CnH2n plus 2. Any two adjacent homologues differ by 1 carbon and 2 hydrogen atoms in their molecular formula. Third, the difference in the molecular mass of any two adjacent homologues is 14 atomic mass unit. And fourth, all the compounds of homologue series show similar chemical properties. Now, what are the functional groups? A saturated hydrocarbon is unreactive, but if we introduce some other atom or group of atom into it, the resulting compound becomes very reactive. This other atom or a group of atoms present in a carbon compound is known as the functional group. Okay, so let's see an example for it. Here is the functional group. Let's see the formula. What are the examples for this are ROH, that is alcohol, prefix is hydroxy, suffix is ol, examples like ethanol. Next functional group is halo, that is RX, prefix is halo, suffix is none, so it becomes chloro, bromo, fluoro. Next is RCHO, that is aldehyde, formyl, that is the prefix name is the formyl or the suffix is al. Example like ethanol, C2H5CHO. Then comes ketone, RCOR-. Prefix oxo, suffix is on. Example like propanone, CH3COCH3. Next is the carboxylic acid, that is RCOOH. Prefix is carboxy and the suffix is oic. Example like ethanoic acid. Example CH3COH. Now the priority of the functional group is carboxylic acid is having the most functional priority. Then comes aldehyde, next is ketone, then comes alcohol, and then finally comes as the halo group. Now how do we nomenclate the compounds having functional groups? Suppose it's having OH, so it becomes propanol as there are 3 carbon atoms. Numbering starts from the functional group end. Here it is COOH, so the carbon of the carboxyl group is taken as 1, and since there are 4 carbons, so it becomes butanoic acid. Similarly, if any halo is added, so halo comes first, it becomes bromopropane on the basis of the number of carbon atoms. Okay, let's see few more examples here. It becomes butone or 2-butanone for ketone. And one more example I've taken is for the aldehyde, that is 1-butanol or but-1-ul. Now, let's see the chemical properties of carbon compounds. First is the substitution reaction. Now, the reaction in which one or more hydrogen atoms of a hydrocarbon are replaced by some other atoms is called substitution reaction. Example like methane when treated with chlorine in presence of sunlight forms CH3Cl plus HCl. Here one hydrogen atom is substituted with one chlorine atom. This reaction can continue till all the hydrogen atoms are replaced. So, the product so formed CH3Cl over there can be continued here, as when we add Cl2 in presence of sunlight, it forms CH2Cl2 plus HCl. This CH2Cl2 when further treated with Cl2 in presence of sunlight forms CHCl3, which is called chloroform, plus HCl. CHCl3 further when treated with chlorine in presence of sunlight forms chloro CCl4 plus HCl. Now, let's see the combustion reaction. Okay, here's for CCl4. By mistake I've written chloroform. Just wait a minute. Let me correct it. This is carbon tetrachloride. Okay, fine. Now, let's see the combustion reaction. It is the process of burning of a carbon compound in air to give CO2, H2O, heat, light. This is known as combustion. This is also called as burning. Suppose methane when treated with oxygen product formed is CO2 and water with heat and light. So carbon and its compounds are used as the fuels because they burn in air, releasing a lot of heat energy. So the saturated hydrocarbons generally burn in air with a blue non-sooty flame. This is because the carbon present in hydrocarbons is comparatively low, which gets oxidized completely by the oxygen present in air. Suppose if the supply of air for burning is reduced, then incomplete combustion takes place, resulting into a sooty flame. Now, if the bottom of the cooking vessels are getting blackened, it means the air holes of the gases are getting blocked. So it needs to be cleaned. Mixture of ethane and air is not used for welding because ethane produces a sooty flame which is not enough to melt metals for welding. Okay, third type of reaction is the addition reaction. This is a characteristic property of unsaturated hydrocarbons. Addition reactions are generally given by double bond, triple bond. Suppose CH2 double bond CH2, that is ethene, when treated with hydrogen in presence of nickel as a catalyst, if heated, gives simply the double bond is broken and both the carbon atoms receives 1 hydrogen. So the product formed is ethane, CH3 single bond CH3. This is called hydrogenation, that is addition of hydrogen to unsaturated hydrocarbon. Similarly, if we add bromine, that is halogen, to double bond, it forms a vicinal dihalide, that is BrCH2 single bond CH2Br. Again, the double bond breaks and both the carbon receives 1 halogen each. So this is halogenation. This process is called halogenation, that is addition of halogen to unsaturated hydrocarbons. Okay. Now, the next is when we combine both, that means hydrogen and halogen, if both are attached to a double bond, CH2 double bond CH2 plus HBr. So one of the double bond breaks and one carbon is receiving 1 halogen, another is receiving the hydrogen. So it forms CH3 CH2Br. This is called hydrohalogenation, that is addition of hydrogen and halogen to an unsaturated hydrocarbon. Okay. We generally use vegetable oils like groundnut oil, cottonseed oil, mustard oil. They all are unsaturated compounds containing double bonds present in it. Addition of hydrogen to these vegetable oil leads to the formation of vegetable ghee or vanaspati ghee. So vegetable oils containing unsaturated fatty acids are good for our health as they can be easily broken inside our body during metabolism. But vegetable ghees are saturated fatty acids which are harmful for health as it becomes really difficult to break during metabolism inside our body. So hope you have understood this